Hey everyone, welcome to this explainer. So today we're taking a completely fascinating and, okay, maybe just a little bit terrifying look into the final fate of reality itself. We're going to break down the absolute latest astrophysical theories and data to understand exactly what happens when the clock finally runs out on the cosmos. So let's dive right in.
It's the ultimate existential question, isn't it? How does it all end? Today we are going on a seriously escalating journey through 5 distinct scientific scenarios. We're going to start with a slow, quiet fade into nothingness, and we'll ramp all the way up to a scenario involving the instant, completely unpredictable deletion of reality. By the end of this explainer, I promise you'll have a totally new perspective on just how fragile our existence really is. Let's start with scenario number 1.
Scenario 1 is known as the Big Freeze, or as I like to call it, simply running out of gas.
Now, contrary to what Hollywood might have us believe, in this scenario, the universe doesn't end with some massive giant explosion or a dramatic tear in the fabric of space. Instead, it literally just runs out of fuel. Every single star that shines and every planet that spins uses up a tiny bit of usable energy. And because the universe is constantly expanding, all those giant clouds of star-building gas are getting spread incredibly thin. Eventually, star formation just stops forever. To really understand the Big Freeze, we have to look at a time frame that is almost incomprehensible. 10 to the power of 100 years. After the last stars burn out, all that will be left is a dark graveyard of dead stars and black holes. And over a mind-boggling amount of time, even those black holes will slowly leak energy back into space and evaporate. The very last black hole will pop out of existence around 10 to the power of 100 years from now. To wrap your head around how insane that number is, imagine if every single atom in the entire universe was actually a universe itself. Even if you counted every single atom within all of those tiny universes combined, you still wouldn't reach that number.
You know, when a massive star dies, it's a loud, dramatic explosion. But when the universe dies in the Big Freeze scenario, it's completely quiet. After that final black hole fades away, there is absolutely nothing left but a cold soup of scattered particles just drifting around in total darkness. The universe isn't dead in the way a star dies, it's dead in the way a math equation is dead once you finish solving it. There's just nothing left to do. But there is a catch here. This slow, quiet retirement only happens if the expansion of space stays steady.
And that brings us to Scenario 2, the Big Rip, the violent car crash of the cosmos.
If the Big Freeze is a slow retirement, the Big Rip is what happens if the expansion of our universe aggressively accelerates totally out of control. Right now, there's this mysterious force called dark energy, and it's pushing galaxies apart, actively fighting against gravity's pull. Scientists track this pushing force with a mathematical number they call W. Now, if W is exactly -1, dark energy is steady, and we get that quiet Big Freeze we just talked about. But if W is even slightly less than -1, we get something scientists call phantom energy. And phantom energy doesn't just push things apart, it stomps on the cosmic gas pedal and never ever lets up. As the universe gets bigger, this phantom energy gets stronger and stronger until it overpowers every single force in nature. I'm talking even the tiny nuclear forces holding your atoms together right now.
The countdown to the end in a Big Rip scenario is terrifyingly precise. 200 million years before the end, giant clusters of galaxies are ripped apart. At 60 million years out, our own Milky Way galaxy dissolves entirely. A few months before the absolute end, the Earth is forcefully detached from the Sun and sent flying into the dark void. Just minutes before the end, the Earth itself crumbles into rubble. And then, in the final microscopic fraction of a second, the atoms themselves are violently shredded to pieces.
So if phantom energy is real, the universe will completely destroy itself in roughly 22 billion years. Now, that might sound like it's safely in the distant future, right? But consider this for a second. The universe is already 13.8 billion years old. That means if the Big Rip is our actual destiny, the universe could be more than halfway through its entire existence right now, and we would have absolutely no way of knowing.
But what if the expansion actually slows down? That leads us to Scenario 3, the Big Crunch, where gravity fights back.
For a really long time, scientists thought a collapse was exactly how it would all end. The idea was kind of thrown out when we discovered dark energy was accelerating the universe's expansion. But recently, some brand new telescope data has made scientists very nervous. It turns out dark energy might actually be losing its strength. Imagine a giant cosmic tug-of-war. You have dark energy pushing things apart and gravity pulling things together. If dark energy gets weak enough, well, gravity finally wins. The expansion of the universe would grind to a halt. It would reverse, and everything that has been flying apart would start falling back together. But the real danger here isn't just galaxies colliding, it's the heat. See, space is filled with freezing leftover background radiation from the Big Bang. As the universe shrinks, that radiation gets compressed. Space basically heats up like an oven. 500,000 years before the end, the empty vacuum of space becomes so insanely hot it literally cooks stars from the outside in. Finally, all matter energy in space is crushed down into a single, infinitely tiny, infinitely heavy point, a singularity.
But wait a second. If all of existence is crushed down into a singularity that looks exactly like the tiny point that originally sparked the Big Bang, that leads us to a massive, mind-bending question. Did we actually end, or did we just bounce?
Which brings us to our fourth scenario, the Big Bounce, the beating heart of the cosmos.
Think about it. What if the universe has more than one life? This theory suggests our universe might just be like a cosmic beating heart, expanding and contracting over and over again in this endless rhythm. Here is how this mathematical reset actually works. Standard physics says a shrinking universe hits infinite density, which totally breaks all of our math. But a theory called loop quantum cosmology fixes this by stating that space actually has a minimum possible size. So, step 1, the universe shrinks. Step 2, it hits that absolute minimum size. Step 3, right before shrinking into nothingness, quantum effects generate a repulsive force so powerful it overpowers gravity itself. And finally, step 4, the universe bounces and a brand new Big Bang erupts. If this is true, our Big Bang wasn't the start of time. It was just the moment the previous universe died. In fact, the famous physicist Roger Penrose even claims you can look up into the sky right now and see faint circular scars left over from black holes that collided in the universe that existed before ours. How wild is that?
However, I should mention the Big Bounce has a pretty significant flaw. Things get messy over time. Every time the universe bounces, it creates a little more disorder and chaos. Think of it kind of like taking a photocopy of a photocopy. Every single time you do it, the image gets a little blurrier and more degraded. Eventually, the universe would get too messy to bounce again. This means, even in a looping scenario, there must have been a very first bounce. And while the bounce gives us a really long timeline to think about, our final scenario does not, at all.
Prepare yourselves for Scenario 5, Vacuum Decay, the instant deletion.
Okay, so every other scenario we've covered today gives us a countdown. Millions, billions, or trillions of years. Vacuum decay? It has absolutely zero countdown. It could end everything right this second. To understand how this works, we need to look at the Higgs field. Empty space isn't actually empty. It's filled with invisible energy fields. The most important one is the Higgs field. It basically dictates the very rules of reality, telling atoms how to stick together and giving matter its mass. It is literally the only reason you, the Earth, and the stars exist. Right now, this field is sitting at a certain energy level. But here is the truly terrifying part. Physicists aren't totally sure it's at its lowest possible energy level. To put that into perspective, imagine you're hiking down a really steep mountain and you step onto a flat ledge. It feels completely solid, so you feel safe. But if you peer over the edge, you realize you aren't actually at the bottom of the valley. A single tiny rock is the only thing keeping you from plummeting all the way down. If the Higgs field is sitting on a cosmic ledge exactly like that, a completely random quantum fluke could push it off. In one tiny region of space, the Higgs field could suddenly drop into a lower energy state, instantly creating a bubble.
And inside that bubble, it is the instant deletion of our reality. The rules of the universe change instantly. Atoms immediately fall apart because chemistry simply stops working. Everything we know is replaced by something totally alien. And worst of all, this bubble expands outward at the speed of light. That means there is absolutely no warning alarm, because the warning would travel at the exact same speed as the destruction itself. You wouldn't even see it coming.
Now, I know this sounds like pure science fiction, but it's not. When scientists discovered the Higgs boson particle back in 2012, they ran the math and realized our universe is sitting dangerously close to that ledge. They actually had to formally promise the public in a real safety paper that their Large Hadron Collider experiments wouldn't accidentally nudge the Higgs field off the ledge and literally delete the universe. They took this very, very seriously.
Vacuum decay is basically a cosmic game of roulette. It could happen in 100 trillion years, or a bubble could be flying at us through space right this very moment. So while our chemistry is still working and reality hasn't been deleted quite yet, make sure you quickly press that like button and subscribe to the channel to see more content like this. The universe might end someday, but until then, let's keep exploring it together. Check out the Explainer playlist linked below, and I'll see you in the next one.